So he is going to be speaking with one arm today. And he also is going to be providing us with a completely different perspective than many of our speakers, because he is not a WordPress person. He is a former member of the CodeIgniter core team, founder of Pyro CMS, and literally wrote the book on APIs that humans would want to use. He's the author of Building APIs You Won't Hate, co-author of PHP the Right Way, and a contributor to PHP Fig and the League of Extraordinary Packages. He's currently a senior software engineer at WeWork. Please put your hands together for Phil Sturgeon.
All right, hello everybody. Never given a talk with one arm before, so this is interesting. I feel like I have a good clicker hand. 1 second. There we go. Thanks for the awesome introduction. Yeah, I'm here today to talk about a whole bunch of kind of API horror stories, like things that go wrong. A lot of people will sit around and talk about, like, oh, I think Flux is going off. Not sure what's happening there. There we go. So a lot of people will sit around and talk about using the proper status code in kind of these airy-fairy things in ways that don't really matter that much. But I'm going to talk about what happens when you get that stuff wrong. Skip the introduction, I guess, because mine was so good. I've been involved in loads of open source stuff for a really long time. I've been programming since I was 11 years old and worked on loads of different open source projects. And recently I've been talking about APIs a whole bunch and doing the book. This is just me trying to, sell the book to you guys. So, from Bristol, living in New York these days. I drove up last night with one arm. Thank God for automatic cars. And yeah, now I work at WeWork. At WeWork, I have bumped into quite a few of these horror stories. So some of them are stories there, and some of them are things I've discovered along the way at previous jobs. I've been doing API work predominantly for the last 5 years, I think. So quite a lot of it. This is my favorite, so I'm starting off with it. I've asked a few of my friends to help out. If you use gets for destructive actions, then Google can find your API, start crawling through the URLs and deleting stuff. Isn't that fun? This guy worked for Rackspace, and somehow Google got onto their feed, because a good REST API should be discoverable from the root, right? So anybody posts a link on Stack Overflow to the root of your API, and then all of a sudden things start getting knocked off as Google. It's like, I wonder what's over here. Oh, nothing. I wonder what's over here. Nothing again. This is strange. Where is all the data? So yeah, when people talk about like which method should you use, like that stuff does matter, because the whole internet has conventions based around how it expects these things to work, and if you mess with those conventions, then you get messed with yourself. On to a WeWork horror story. Who likes to look at this graph? When I got there were a lot of different systems talking to each other, and one of the big problems was on move-in day. There's a third-party system that handles keycards, right? Like there's WeWorks here in Boston. Anyone been to a WeWork, kind of what a co-working space, right? And so on the first of the month, everyone moves in. They want to get keycards. To activate those keycards, they have to go to a third-party system. That third-party system's kind of crappy. But a lot of these requests were being made in the thread. So you can see here from the graph, a whole bunch of this stuff is web external, right? All this massive stuff is web external. And some of this smaller stuff is request queuing because it's waiting for a chance to have an active thread to work on. It says 4.5 seconds. This is like a nice average time. There were outliers that don't bother showing up on New Relic graphs of like 30 seconds. It was really bad. So a lot of the time, because this is happening in the web thread, slow stuff, it would fail. So there's a user sitting there trying something, nope, trying something, nope, and it's no good for anyone. So we fixed it by not doing slow stuff. This is like a step one for any API or any app, anything. Like, don't make the user wait for slow things to happen. You want to async as much stuff as possible. And then you want to tell clients where to get updates. There's a bunch of ways you can do this, but like if the client needs to know whether something worked or not, that doesn't mean it has to happen in that one thread, right? You can just return early, wait for the async to do something, and then use WebSockets, webhooks, like callbacks. You can use long polling. Like I would genuinely prefer you implement a long polling approach than just like spend 30 seconds doing something. But the funny part of this story is that make sure that your async code is actually faster than doing it otherwise. We had some really big, we had some reasonable size images coming in between half a meg and a meg. And we didn't want to put them straight onto S3 because that would be slow, right? You don't want to do web requests in the thread, is the general thinking. But maybe if your servers live inside AWS, you can think of S3 as more of a data store than you can think of it as an external API, right? So trying to avoid these image uploads, we were actually shoving things into Redis, and because those images were a meg, and then we base64 encoded them, it made them 33% bigger. So we're shoving these massive images into Redis, which was then crashing the Redis server, and slowing down the web thread so much that it caused a problem. So if you look at this, this is the clever bit where we implemented all the async code, and then this chunk here of Redis is where Redis started to struggle because we were jamming things into the queue. So be very careful with how you async stuff. I think we ended up just shoving the images into like Postgres as a binary field and then pulling them out later. And now everything is like 400 milliseconds at the worst. This is another really fun performance issue we had. The user's endpoint, there's either the user's resource or the user's collection. Passes in the ID. No one ever actually checks to see if the ID is set or not. So somehow or other, through some magic of Ruby extension, users 123, they thought they were sending the ID. Turns out, really it's kind of just being shoved in as a nil, which turns up as users. The user's endpoint wasn't paginated. So every single time a client tries to call for a user, but they haven't checked their ID and it's empty, which is apparently quite a lot, the entire server would crash because it was trying to fetch and serialize 4,000 users at the same time. Just the dumbest issue to happen, right? So defensive routing, or routing in this country, is something I think is quite a good idea. Like a lot of people will generally, they'll generally support trailing slashes, right? But the trouble is, a trailing slash to me looks like you tried to find something in there but didn't mention the thing you were looking for. So maybe that should be a 404, right? You can route them differently. But even if you don't worry about that, pagination would have helped. If you try calling up, if you accidentally call the collection and you only get 100 things or 20 things instead of 4,000 things, literally all the database, then you'd have fixed that whole mistake, right? Limits, again, even if you aren't doing pagination, maybe there's not ever really a need for all of your users or all of your whatevers to be fetched. So 404s are probably a better idea. Like, you want to be a little bit error heavy when you're designing an API, because if there's a problem, someone finds out and then they can fix it. But if you just kind of do whatever, like the most annoying thing about that error wasn't the fact that the annoying thing about that performance issue is that the response that took a really long time to happen and crashed all our servers wasn't even useful, because they're looking for a single object and they're getting an array of loads of stuff or an empty timeout. So yeah, throw errors more often. If you're doing pagination, make sure you actually limit how much you can paginate. If you don't put an upper bound and a lower bound, people can either request -1, which is all of your data, or they can request 1,000,000, and that becomes a DDoS vector. So you think you were clever by adding pagination. If you don't do this, then you are still in trouble. Who has worked with includes? I'm pretty sure the WordPress API has includes, right? Seems like a really cool idea. With REST, the whole idea is that, here's resource A, and if you want some resource B, you can go over there and get it. But mobile developers don't like doing that. They're working with slow networks. They want to make as few requests as possible. So what ends up happening is you get these massive includes. And we had a few of these at the last company. So basically what was happening is that our entire API, we designed this entire thing, all the resources, everything, and we kind of found out that people were ignoring most of the endpoints, and both the web team and the iOS team, they both had this like one single entry point where they just included everything the entire app could possibly need to know. So it was like, get /me, and it's a carpooling company, so it was trips and passengers and things like that. So it was, get me, get trips.passengers, get trips.passengers.avatar, get trips.driver, get trips.driver.friends, like all this crazy stuff. And it was taking like 45 seconds to respond. I said to them, if that's the way we want to go, we didn't need an API. You could just curl down an SQL-lite version of the database and you can query it locally. Like, that would actually be more effective. So all you have to do there really is restrict the includes people can have. Your API isn't really meant to be a HTTP interface for SQL, so you don't want to let the client do literally anything. You want to cover as many basic paths as possible, and then when things come outside of that use case, they can just make another request. And if you find a lot of people are having trouble with specific thing, then you can maybe add that, but always give a little bit of pushback to adding includes and make sure they're actually necessary. Quick, easy win, SSL. It's free now. No one has any excuse. It used to be like not that much, and now it's nothing. So let's encrypt.org. That helps. Instagram didn't bother. They just did everything on HTTP, and even when Facebook took it over, they had this really cool thing where you could just like sit in a coffee shop and get someone's session ID and log in as them, and it was fine. Maybe if you use SSL, they can't do that, or if they can, it's much harder. Yeah, who has worked with UUIDs? Not very many folks. Out of interest, just to gauge the crowd, I should have done this before. Who's actually designing their own APIs, like building them at work? Cool. Okay. So a lot of you folks are just kind of using them, I guess. Not just. You're just as good at developers. Just some of this stuff is about designing, and I guess it's good to know like why they should be designed that way. But so, as developers, especially as PHP developers and Ruby developers, maybe some of us, we're taught to think that auto-incrementing IDs are the best, right? Like everything should be auto-incrementing ID. Whenever you have a table, it should always be that. The trouble with auto-incrementing IDs is that it makes it very easy to download your entire database. Who's ever seen this? You go to resource/1, resource/2/3/4. You can make a script that just adds one and saves stuff. So I had a couple of friends who were working for a startup on a startup accelerator in the UK, and they were making, it was this really cool idea. It was when you're walking around, you see some cool graffiti or some like unknown artwork, you can snap a photograph and like, it's like Foursquare for art or something, I guess. But they had this really unique, awesome database of artwork and graffiti and installations all over the UK. And they spent a bit of money making an app, and they built the API. And someone just saved all their data and made a better app, and now they're bankrupt. Like, it's a genuine problem. And although you might think that, well, if data's in an API, then it's public, it's not necessarily publicly browsable from the root collection. And that's something else you should think about. If like data is geospaced, then to download all of their data, they'd have to make a script that pretended to be here, and then here, and then here, and then kind of move across the map. And you can detect that sort of behavior. And you can use rate limits to make it so that if people are illegally downloading all your data, you at least know about it and can kind of get ready for the trouble instead of just going bankrupt. So UUIDs kind of help that because they're just a big old string of like random numbers. And although they can be a little bit unperformant, there are ways to tweak them. So if you just search for UUID performance, there's help. This one goes back to the initial kind of problem with the key cards on move-ins, and we were using a third-party system who basically said, no, all of our requests respond within 100 milliseconds. Don't think so. 2 minutes. What was pretty awesome about that was we found out that their logging implementation, their logging for response times, would actually give up after a certain amount of time. So if there was anything more than like a second or two, it would just assume that it must have been complete and then shut down. So when they looked at their records, they were like, no, our records say that nothing slow happened. I'm like, right, because you're not actually training slow things. What's happening? So yeah, using RunScope, we implemented, who's used RunScope before? Cool, not very many people. If you're ever building an API, or even if you're working on a mobile client, RunScope is really awesome. If you folks are using like the WordPress API and you have a mobile developer in staging, or even in production sometimes, you can funnel traffic through RunScope so that you can catch every request, right? Every single header, query parameter, everything in the URL, everything in the body, payload, the response, everything is recorded. And you can just look through that stuff to see what happened. And it was really helpful. Like I said, the company was kind of in a really bad way. Like if we had another bad move-in day, then some people were going to get seriously slapped on the wrists. And we shoved this in, and we helped debug this third-party server issues ourselves. So RunScope's really cool. You can use an environment variable to switch it on and off and funnel stuff through, but it really helps. Although to use RunScope properly, or to use most web stuff expects you to use the web properly. So when I talked about using the right kind of conventions, this is a pretty important thing. If you have server errors that happen and they are 200 OK, New Relic, RunScope, none of those things know that there was a problem. So if you look here, we had some stuff that was 502, and I was like, hey guys, why is 502 happening here? But then these errors are just like API error 5, whatever that means, with the 200 OK. And they were like, oh, we're sorry, that was meant to be 200. That's the wrong way around. They wanted their entire API to be 200 because their theory was if it returns a response, then it's okay. And that's not really how that works. Like if I'm trying to place a financial transaction for $1 million and then this like a poorly configured client's just like, that's fine, but it didn't work. That's really upsetting to me. So only Insanity Wolf does that. Please don't be the Insanity Wolf. A really common thing people will say is like, oh, well, we built this API before REST was cool. Firstly, REST has never been cool, but it is popular now at least. And REST is nothing to do with returning status codes properly. REST has nothing to do with HTTP at all. Just ignore those concepts entirely. Separate those concepts. REST is the approach that you should utilize the uniform interface of whatever transportation layer you're in, and if that is HTTP, then you should use it properly. But REST, they're two separate things. REST says use HTTP properly. You can still use HTTP properly if you're not using REST. So if you're doing an RPC API, which is totally fine, you still want to use status codes. Shout at anyone you see doing otherwise, because the internet breaks when people don't. More stuff on errors. I talk about errors quite a lot because people, when they're building APIs and working with APIs, they only really think about the happy path, right? I want to send this data and then I'll get this response. I mean, that's great, but that's not how it works. Like when you're coding, you don't always just think about the best case scenario. You're meant to think about edge cases, about problems. And when problems happen, you want to be able to, as a human, you want to be able to see what's going on. And as a computer, you want to be able to respond to it accurately. So this error is what Facebook used to do, and it really did my head in. Does anyone recognize this from back in the day? Basically, if anything went wrong with trying to make an OAuth request in Facebook, it would give you something OAuth-y happened, thanks, and a message that was different with like variables in it. So you couldn't even match the entirety of the string to say, oh, if this happened, you'd have to do like substring matching. So you'd have to write code that would say, okay, if I get an error back and it says session has expired in there somewhere, then I know that I should try and use a refresh token. But if it says something else, like that message could have said, you're trying to use a page token for a user action, like there's different types of tokens and stuff. I just wouldn't know about it. So yeah, you need to be able to return things that make sense to a computer, and you want to return things that make sense to humans, which YouTube do not do. Anyone know what that means? You'd look at it and you'd think, well, I don't know why they've got... A lot of people are trying to work out in design, should I have one error or an array of errors? And YouTube just went, both. Everyone's happy now, perfect. Maybe they were like switching from one approach to the other and that was deprecation, but it just looked really silly. But the main problem for me is that it says, okay, no filter provided, or selected, sorry. So it's fair to think, all right, filter, no filter selected. Oh, I need to add a filter parameter to my query string, right? Nope. Mine equals true. Okay. The only way I could find that out was because somebody really sarcastically said, oh, read the documentation on a Stack Overflow post and linked to the documentation that didn't exist anymore because YouTube got rid of it. And I think I managed to get onto like the Wayback Archive and find like an old version of that page and then find that mine equals true was missing. But they could have just put like, you're missing mine equals true in the error. That would have been great. So yeah, errors should be well documented. If you use the JSON-API specification, whether you like it or not, in entirety, the error format is really cool. And the error format says like, put a link to the documentation, have a title, which doesn't really change based on the instance of the error, and then have like more information about it. You could even use JSON path selectors, like XML path, to say, you can point to the attribute that's missing. You can say data/attribute/title is empty, and then people and computers know exactly what the problem is. So another thing where humans and computers both need to know how things work, you should retry failures from the client side. Like if something goes wrong, don't immediately make that the client's problem unless the client did it wrong. So any sort of 5 anything can probably be retried. 500, 503, all those things mean there was a problem with the server, but maybe next time there won't be a problem with the server. Some client-side things can be retried, but you shouldn't retry all of them. So working with middlewares is pretty important for this stuff. You can have HTTP client middleware. I think Guzzle has a bunch of this, and you say, when I get the response for this instance, look through these different things. But if you retry all client errors, you might have a bit of a problem. Hello.js was basically, it's like OmniAuth, or didn't the League make one of these? It's one of those packages where you can log into any OAuth provider with a standard interface. And normally, the internet uses 429 to say rate limit exceeded. But Google, for some reason, was using 403. And that meant that when Hello.js saw a 403 come back, it just retried it. And so we were getting a rate limit response, and it's decided to retry it. All of our every single web instance of our app was basically contributing to a DDoS on our rate limits, because this one thing quite rightly had the assumption like, oh, forbidden, okay, well I should retry that with the refresh token. Oh wait, it says 403 again, and it just kept on retrying. So that's another reason why Google's not really helping us out when they kind of ignore conventions to do their own thing. It was fixed with a pull request, but it's an annoying thing. I just put that in because I like it. If anyone's ever stuck with which status code to use, go and look at the dogs and see if it fits your scenario. There's also HTTP status cats, which is a popular alternative. I'm working on HTTP status turtles because I like my turtle Stoford. He's a good boy. Ooh, I think I've got some... Yeah, interestingly, my clicker doesn't go down. It's a slight failure on this. Oh yeah, cool. So I usually skip that slide because I forget it's there. So don't retry all failures. Slack have a really good approach for how too many requests should happen. So if you go over the rate limiting, it will say, whoa there, slow your roll. You can retry after 30 seconds. So you have your client, you just pop up a little message maybe saying like, hold on, retrying, just like Slack does. When you open up Slack, and things don't always work particularly quickly, or ever quickly, it will basically say reconnecting. Okay, reconnecting. All right, we'll retry in 30 seconds. You can do stuff like that, and it's more important to give useful feedback to your clients than it is to leave them stuck with like a white page where they're like, I don't know what's happening, or to keep spamming them with errors. Because if you can retry it in 30 seconds, and you know that you can retry it in 30 seconds, you don't need to make them refill in the form or click more buttons, right? It just makes it better for the user. This is a really fun one. We actually had this at work in but Twitter really did it. Twitter somehow were caching 429 responses, like errors, rate limit errors, for other users. So you come along and you make your first request ever. You're like, this is really exciting. I'm going to go and get this thing from Twitter. And it says, no, you've done this too much already. You can't do this. What? It's for someone else. The problem was they're using Varnish. Anyone here use Varnish? Okay, Varnish is really cool, but you have to configure it properly. It's basically a HTTP proxy, and so you make requests through the proxy, and if it has awareness of the cache, you get a cache hit, and it totally leaves your server alone. So this is really useful for anyone. Fastly is a hosted service; it works really well. But yeah, if you cache it when things go wrong, and you cache that for other people, then it kind of sucks. We had a problem at work where we were caching 404s accidentally. Oh yeah, that was just a slightly more up close and personal. Yeah, so here are the ones that are cached by default, which is why I'm so confused about how Twitter managed to cache theirs. They must have just been like, cache all the things. Don't know how or why, but by default it will cache these things, and this one can be trouble. Varnish was built for the internet in general, and so you have to make a pretty serious decision about whether you want 404s to be cached or not, because theoretically, if something doesn't exist, and it's probably not going to exist really soon, but you can also get race conditions. So if you have something being put into a queue, and then a client goes to check if it's there, and they get a no, by default, I think it's cached for 10 minutes. So for 10 minutes, that thing doesn't exist in your app at all. So we knocked it down to like 30 seconds, which still prevents us from DDoS, but means that data actually exists when it's expected. Ah, lovely formatting. You can tell I added that slide at about 1 in the morning. All Twitter would have had to have done is just say, if the status code is 429, then set the TTL to 0 seconds, and it invalidates the cache immediately. So, talking over HTTP, I've already said, like, people treat talking to APIs like calling a local function. They just expect it to, work every time, and things will be fine. They build these interfaces based around, like, I'm going to be here, and then after this post request has succeeded, I'm going to be here, and this thing will happen. And it's always the happy path. You have to spend a lot more time worrying about what can go wrong. And so expect the worst from everyone. Just be a paranoid, deranged person. Because if you're expecting JSON, you might not get JSON. You might get HTML, right? I've seen some really weird exceptions be bubbled up to the user because Heroku returned a status page because they're temporarily down, and they didn't know that you were usually serving JSON, so they've just shoved HTML in there. Then all of your code is trying to pass angle brackets, and it's getting really confused. It might not even have any response, nothing. It might never come. The request might hang for a really long time. And if you don't have your timeouts configured, or your client, your HTTP client, so Guzzle or whatever, that might not be configured to have default timeouts. So you're just sitting there waiting for a minute or two, waiting for this thing to respond. And so you see a lot of code like this. This is Ruby, I apologize. I'm a traitor these days, but they're just trying to get something, and they're like, all right, do the thing, and then just immediately assume it worked, and whatever comes back, shove it into JSON, right? And then we're going to assume that this structure exists because they don't use status codes. They have success or not in the body, like it's the 90s. And then we're going to return the response, and otherwise it's going to be not found, and then else just have a panic about something, maybe. But even the else assumes that that's there, right? What if they change their format? What if something's gone wrong? So bad, really bad. It led to a lot of errors like this. We just had loads of errors in rollbar, and it would just say undefined method angle bracket for nil class. That's what happens when you try to access things that don't exist. So the this was nil, and therefore it didn't have like array access. PHP will give you another just as useful error message, I'm sure. And yeah, so step one. This is super relevant for the people that aren't building them, but are working with APIs, is rescue anything that goes wrong. Like if you try parsing, so this is confusing syntax actually. So in Ruby, you can rescue directly off of a method declaration. So just imagine there's a big old try-catch around the entire contents of the method. But you want to catch a parser error and then output an obvious thing that says, service returned invalid JSON data. And maybe you want to put the actual message in there, or you throw that into rollbar so people can see what the actual error was and fix it very quickly. You'll never prevent all errors from happening, but what you do want to do is make it so painfully obvious that there's a problem and what the problem is that people can fix it really quickly instead of having to like dig around in the code to find out what's going wrong. Oh, and also you can kind of catch this in your app and say, oh, there was a HTTP server error, and you can respond to that more intelligently. So yeah, the response might be empty if it's a timeout. Like timeouts just don't, it's just nothing. You're like, I'm asking for something and then nothing happens. They really suck, and we had a lot of them at WeWork. Still do sometimes. But Yeah, put in a check that says if the body is empty, then just say, hey, why did they return an empty body? So you've got 2 checks in there. And never assume the shape of the data either. So as I said about the kind of assuming that response is there, check. If you're expecting response and you're expecting a code, then check and throw an error that you control to that. You don't want your clients, your apps, your web app, whatever, trying to catch 100 different errors from 100 different places, having to know about like this provider and that provider. Just throw errors that you control and then catch them in a way that you control as well. This is another fun story about documentation not being optional. It's a fun joke. Apparently UPS have like a book. You can order their documentation and it like kills the postman every time, but which is ironic seeing as they're a postal company. But basically you want to build documentation. Who here has worked with documentation for APIs? That's depressing. So anyone want to shout out, what do you use to document APIs? Do you write it by hand? Swagger. Okay, cool. There's Swagger, there's RAML, and there's API Blueprint, and then some other thing I can't remember. And any one of those you want to use is totally fine. The general idea is that you define all the fields, and you make these like data structures. You can also use JSON schema, which is another cool thing. JSON schema or RAML or any of these things can define the shape of resources, what the fields are, whether they're required, whether they're numbers or arrays or whatever else. And then you put them into the documentation that says, right, on this endpoint, we expect this in the body, and this will be the response, right? So you can build this documentation really easily, and these tools make it so easy. I've actually got a video somewhere, I don't know where it's hiding, there it is. I did a video, bit.ly API doc video, and it's, just read it, just watch it, it helps. One of the last things I'll say, I flew through this, so I hope some people have questions, or I can do a little GraphQL versus REST thing, so I've been meaning to talk about that for a long time. Make sure your services aren't lying to each other. A lot of people, when they build an API, they build their API in isolation. So they know that their API works, and as long as you send it the right request, it will give you this response. And then people save those example responses and put them into their app. So the web app team will take a copy of a response from that you made for version 1, and they'll keep on testing against that stub. But when you test against static stubs like that, you're ignoring the fact that APIs change. And although there's meant to be API versioning and things like that, a lot of APIs use the concept of evolution, which is what they should really be doing instead of versioning. And so they'll add a field, and they'll remove a field, and the field might change a little bit. And so if you have these like old static stubs in your test, then your app knows that it works with this contract, and the API knows that it works with this different contract, but there's no integration. They don't work together. A really strong way of fixing that is by using strong parameters. Strong parameters is a concept in Ruby that somebody ported to PHP, and it's not a super well-used package, but you can, in your API, basically say, we require these fields, and we permit these fields that are optional. But if anyone sends an extra field through, it should error, right? And whether you want to have it error on or just ignore it depends on the environment. I quite like to have development and staging be super paranoid and aggressive about stuff, and then production be a little bit more lax with this stuff. So in development or staging, if I try sending through a field that doesn't exist, then it will error. Benefit of this, last company, there was some field that we talked about like in the early stages, like alpha, and it was, I think it was like has iPhone, right? It's just this little field that you check and you say you have an iPhone. And that would help us work out, it was for the carpooling company, and we wanted to work out if we should send an iPhone to the driver of these carpools, because we're trying to help them out. I think then there was some decision that we didn't need that field, so we removed it from the API, but we didn't remove it from the web app. So the web app was sending has iPhone, the field was still there, no one noticed for a year. For a year we have this field being thrown into a black hole. And then a new boss came in. They're like, right, I want to work out. No, it wasn't has iPhone. It was previous carpool. We want to work out if they used to carpool before this, or whether this was their first carpool. And a new boss came in, and they were like, right, I'd love to find out how many people clicked yes on that previous carpool thing. And the API team was like, we don't have that. So we were screwed. And all we would have had to done there is implement strong parameters and require them, an error to people, and then at some point over the last year, somebody would have noticed, oh wait, there's an error coming from this API, instead of just ditching data into the bin. So a good way of doing this is VCR stubs. Has anyone worked with VCR before? Nice. Yeah, two people. Again, it's like a Ruby thing that has been brought over to PHP, and there are other things for JavaScript. Does anyone know of a VCR for JavaScript? Probably called VCR.
It's called Node VCR. I don't know if it's any good.
Okay, but it exists. Good. So yeah, the idea there is that you can put VCR into a couple of different modes. You can put it in record mode, and it will record any outgoing web requests and then save the response into cassettes, because they're hilarious and it's all themed. And you can have these different cassette tapes and whatever. Sorry?
So 80s.
Yeah, it really is. There's a lot of new developers like, what is this cassette you speak of? But you record the responses, and then next time you're running your test suite, you don't run it in record mode, and it will use those stubs, which is great, because not only, I've had test suites that like don't run unless you're online, and who's had that before? It sucks. Like, oh, I need to work on this really quick feature while I'm on a bus for the next 2 hours. Like, I'm taking the mega bus back to New York, I'm really sad about it. Need to work on this feature because I'm stuck on a bus and I can't because it has to talk to these 3 different Heroku services. So if you use VCR stubs, then it will short circuit that request with the old request. A really cool thing you can do is have auto expire on your cassettes. They didn't come up with a fun theme name for that, but you can have them. You can have it re-record after 30 days. So instead of having this like year-old copy of the contract, you have a 30-day-old copy of the contract. And maybe that runs on a monthly Jenkins build or something. And as well as having your tests, you should also use Docker Compose, or Kubernetes is cool now. So you have your actual API and any other actual services that it requires running with a real version of the client. So you can do this on Jenkins or Travis or wherever. And so when you push some code, it will not only check your version of the tests against your version of the contracts, but it will test all of the apps actually work together and there's no data mismatch, because that is a really big problem. Data mismatch has screwed us in the past. I have a book about APIs. It's a little old, but it's generally about all the theory of designing stuff. I'm currently working on one called, I need a funny name for it, but working on one for front-end developers as well. So if there are any front-end developers here that have had some really big gripes with working with APIs, I'd love to talk to you folks. It's going to have a lot of stuff about timeouts and handling errors and responses and differences between RPC and REST and why they're fine and okay and things like that. But this one covers a lot of the design choices and things I talked about today. And there's a coupon code, WordPress, which makes it $10. Normally it's $1 million, so gotta pay off that green card somehow. Thank you very much, folks. I think I have plenty of time for questions.
Thank you, Phil. Does anyone have any questions for Phil? So I have a question for you, because I read your blog. There are many different options for APIs. So you have REST APIs, you have RPC, you have GraphQL now. If you were designing an API from scratch just for content, which of those 3 do you think you would use, or you would start your exploration?
Great question. I'll be half an hour with the response. So the quick 10 minutes. Okay. The quick overview is that RPC is generally kind of frowned upon and people hate it, and it's not bad, it's just really good for actions. So if you're think about RPC as triggering a function, calling a thing, passing a few arguments. Where RPC picked up all of the flack was that people were using it for content-rich websites. So that you have all these different functions create blog, update blog, get blogs by user, get blogs by this, get blogs by that. So RPC ends up being pretty disgusting and verbose for what a REST API is useful for. So I would probably go with REST a lot of the time. Where the REST versus GraphQL thing comes in is really interesting. GraphQL puts a lot of the power on the client side, which REST is entirely trying to avoid. Like the whole point of REST is like, here is your data. It's generic. It can be accessed in any way. We don't care about the client. You can make a few requests. You can shape it how you want. You often get too much data because you get the entire response. There's ways that you can fix that. JSON-API has sparse field sets, so you can trim the response down by saying, I want these fields. I'd like to include this stuff. So a lot of the advertised advantages of GraphQL can be achieved through REST. But at a certain point, you find yourself building this like query language into REST, where you like fetch things where this field is greater than 5, and you have to build your own syntax for that, and you have to do all this stuff. So if you start to find that your REST API is becoming a query language, then that is when adding a GraphQL endpoint would probably make sense. So you don't need to necessarily do one or the other. A lot of people they'll start off with REST, and then as they get to these kind of very specific edge cases where a specific client is struggling or suffering, you can add in a GraphQL endpoint. And to avoid duplicating work, a really cool thing I've seen some people start to do, and I'm starting to do at WeWork, is if you define JSON schema for everything, all of your resources have JSON schema, then you can build JSON schema to GraphQL type, kind of transpiler or whatever converter. So you can have, here is the shape of my REST data, and here is the shape of my GraphQL data based on the same conventions, and then just offer both. A lot of people also will use GraphQL to talk to multiple REST APIs, and we have this problem at WeWork where there's one web app that has to talk to like 15 different APIs, and one of them's OAuth 1, and one of them's this other thing, and the web app gets like a lot of this like built-in knowledge about how 100 different systems work. Whereas with GraphQL, you can make this like gateway thing and say, I would like these fields from these endpoints, and then it will go off and like fetch the things for you and build one single HTTP request that goes over the slow internet to the client that's very tailored to what they want. So there's still some performance issues in the back end of making multiple requests, but if it's using Go or something, then you can kind of stitch them all together and do things asynchronously, and that works out quite well. So the answer is either probably start with REST because it's more generic and it's what people know, it's more clients that support it, and then maybe add GraphQL later.
Very cool. Anyone else have a question?
Cool.
All right. Well, thank you very much, Phil.